Let us have some brief information regarding the design of RCC structure. When you are going to design any RCC structural element, just like RCC beam, RCC slab, RCC column, footing, etc. So first of all, we must be clear that what are the objectives of design. If you are clear in the objectives of the design, then you can design accordingly so that all the objectives can be met out. Now, what is the main objective? Main objective of any structure designer is to produce ductile behavior in RCC member such that it is available to safeguard human life. Because if the material is brittle, suppose you have designed a member which is brittle, so when load it is subjected to service load, then at a particular point it will collapse. So brittle material will collapse and the whole building can collapse. But if the member is truly ductile, then what will happen? It will be, when it's subjected to loading, what will happen? It will start bending. And when there is a bending, that means before failure of any structural component, it will give us a lot of warning. That means just on viewing that structure, you are able to understand that, and later on it will be going to fail. So failure can be avoided. So that means when you are going to design a structure, its behavior should be ductile behavior, which will give sufficient warning sign. Now, structure design must satisfy some basic requirement. So, very first is stability. Your structure must be stable. Stable means any type of overturning, sliding, or buckling of the structure or any part of it under the action of load should be prevented. Otherwise, its stability will lose and the structure will not remain stable and a failure can occur. Second important aspect is strength of the member. So structural components should be of sufficient strength so that they can resist the various type of loads, forces or movements which are going to happen due to the service loads when it is under the utilization. Third, very important, is serviceability. Serviceability means when the structure is exposed to service load. And so we are saying that structure should perform satisfactorily for the intended purpose, for the purpose for which purpose it is built. So it should fulfill all the purposes. Its performance should be very much satisfactorily under service load condition. That means it should have adequate stiffness, which is required. And if there is any type of deflection, crack width, permeability, etc., then these type of happenings, that means deflection, crack width, and permeability, it must be within permissible limits. And these permissible limits are clearly mentioned in various Indian standard codes, just as IS 456. Now, what are the design methods which we can use, or design methods which are adopted and are currently in practice? So first of all, our guidelines will be available in the code IS 456. So what code is saying? You can use the limit state design method. That means limit state method of design of RCC structures as per IS 456 recommendations. Secondly, you can also use the earlier method of design, that is working stress method, but code is saying that wherever limit state method cannot be adopted conveniently, you can use working stress method. Otherwise, currently or in these days, we have to adopt this limit state method of design. In the later lectures, we will be able to understand that what is the difference between working stress method and limit state method, and which one is better and if any one is better, why it is better. Now some basic codes which you have to be kept with you when you are going to design. So some of the important codes, first of all, we know that it is IS 456 2000 version, plain and reinforced concrete code of practice. Now how to estimate the various type of loads which can occur. That means how to assume the loads. So some guidelines are given. There is a series of codes IS 875. In part 1, information regarding the dead loads is given. In part 2, imposed or live load information is available. Part 3 is devoted to wind loads wherever structures are subjected to winds of high velocity. Part 4 is devoted to snow load. Part 5, special loads and load combinations. Later on you will be able to understand in all the details. And whenever you have to design a structure so that it should be earthquake resistant, then you have to refer the guidelines given in IS 1893 2002.